All right, so remember I said you can factor using a graph. So this is that process, right? In the homework we did grouping, GCF, synthetic division. This is the fourth one that you know. Because if the polynomials were divided, if the polynomial divided, what numbers would give a remainder of 0? Well, we learned with the remainder theorem that that remainder is the y value for any x that you try to divide by, right? So if you divide by something, some number, and you get a remainder of 0, that x and that y are a point, and they're not just a point, they're a what? An x-intercept, right? A remainder of 0 is an x-intercept. Okay? So with that in mind, with that knowledge in mind, we know that the three numbers that would happen for are our three x-intercepts, which are what? Yep. So it would be 1, 3, and 5. Right? And if they're x-intercepts and they have a remainder of 0, that also makes them, starts with an R, roots. And why is it important to recognize that? Because roots can turn into what? Factors, right? And when we start finding factors, we're starting to find factored form. So I would say f of x or y equals, and because I know it's negative 1 for a, again, I just told you what your a was, not to confuse you, just so you actually didn't try to find it, because eventually you will have to find it. And then, okay, I know my three roots. I got three x-intercepts. How many parentheses do you think I'll need? 6. Somebody say 6? Somebody say 6, though? Because somebody said it in my other class, too, and I want to clear up confusion if there's confusion there. Why 6? So there's 3. Think about a parabola, right? When you got 2 roots, you got 2 parentheses. Well, this is cubic, 3 x-intercepts, 3 parentheses, right? Okay. So 3 parentheses, and now I just turn my roots into factors. My first root was 1, so my factor must be x minus 1. My second root was 3, so my factor must be x minus 3. And then x minus 5. Okay? Remember, what I did is I started with this, right? And now I have this, right? I factored that using the graph. If I went into Desmos and I put that in, I would see a picture of this graph, right? And then if I put that in, what would I see? The same. If I have my negative, you will. Yeah, the same exact thing, right? Because it's the same thing, it's just in a different form. Okay? All right. So, last question. If the polynomial was divided by x minus 4, what would the remainder be? 3, right? Because with synthetic division, I would put a positive 4 on the outside, and I know the y that goes with that is 3, right? 4, 3. So 3 is your answer there, right? We're looking for the output for that input. Okay. Questions on that? Any? Okay. So that's the remainder theorem, factoring using a graph. That's where we're coming from. There's going to be 2 more methods of factoring that you'll learn today. Okay? And again, we're still factoring. We're not solving. We're just breaking down a big piece into smaller pieces that multiply. Okay? So the next thing we're going to talk about is called quadratic form. Okay? Quadratic form. Okay, so notice I put the word form in parentheses because it's in the form that kind of looks like a quadratic. What does a quadratic look like in standard form? Well, it's got an x squared, it's got an x, and it's got a number, right? There's an x squared, there's an x, there's a number, okay? So let's do a review, right? I know that most of you are solid on magic x, but let's drill into it, make sure we recognize why we're doing what we're doing, and we're not just going through motions, right? Kind of like a throwback to why we do magic x, okay? So we're doing magic x to factor this quadratic. This is from last unit, right? So remember what I want to do is I want to get this to smaller things that are being multiplied. And I'm trying to figure out what those things are, right, when I factor. And magic x helps me because I know that in order to get those, they would need to multiply to give me 12, and they would need to add to give me 7 because that's my C and that's my B, right? Now, the reason we choose multiplying and adding is because that's how FOIL works, right? There's a multiplication and then there's a combining of like terms. That's the adding, right? There's a reason we use magic x. So what are those two numbers that multiply to give you 12, add to give you 7? 3 and 4, right? So what do I do next? Well, I put plus 3 and I put plus 4. I don't flip the signs. I flip signs when I'm solving, not when I'm factoring, okay? And that's a key mistake. Now, what do we always just drop into that other spot? X. But why do we do that, besides the fact that we just do it every time? Because I need the x squared. Does everybody see that, right? Remember that when you factor, you're finding smaller things that multiply to give you the bigger thing. So think about that definition. You should be able to get back to the bigger thing if you wanted to. If I did this correctly, I should be able to go that way, right? And the first part of FOIL, the first part of box method, would be this times this, which is x times x, which has to give me x squared. That's why we put an x in there, right? And we'll prove it, right? If I did box method to prove that I got the right answer, I would go x plus 3 and x plus 4. The first thing I would do is x times x, which gives me that x squared I'm looking for, plus 3x plus 4x gives me that 7 I was looking for. And then 4 times 3 gives me that 12 I was looking for. That's why we do magic x. It's all part of this process, right? Okay. Now, questions on that before we continue? Makes sense, right? The why of it all. Okay. So why did I go through this like detailed breakdown of magic x and box method, right? Because look what we have here. X to the 4th plus 7x squared plus 12. So to the 4th to the 2nd to a number, okay? It kind of looks like a what? I mean, the word quadratic equation means x squared is the highest degree, right? But it kind of almost looks like a quadratic equation, right? Even though it's to the 4th. It's in that same format, right? So that's why we say quadratic form. This is not a quadratic, but it's in quadratic form. It's got the same beats. It's got something to the 4th, something to the squared, and then a number. It just kind of leveled up a little bit. Because it's in the same form, we can do the same trick. Okay? So, what is that trick that we used? Magic x. So, I chose the same number, so it's going to be the same thing. We got 12 on the top, 7 on the bottom, 4 and 3. Right? But remember, I'm trying to find something that would multiply to give me this bigger thing. Right? So, when I go to do this, just be very careful. Yep, it's plus 4, and yep, it's plus 3. But what needs to go in that first spot? X squared. Because I'm trying to get to x to the 4th if I'm going back, right? So I need x squared here, and I need x squared here. And that'll get me to my x to the 4th if I ever needed to go back, right? We can prove it with a box if we want to, right? X squared plus 4, x squared plus 3. You don't have to check your work every time. I'm just proving this works, right? Gives me x to the 4th plus 3x squared plus 4x squared and plus 12. That gives me my x to the 4th. This is my 7x squared, 4 plus 3, and then 12 is my 12, right? So we need those x squareds if we want to be able to ever get back, right? If this is our journey and we want to be able to return, we need to properly put in the right pieces. Okay? All right, so does that make sense? You're using magic x, but you have to use x squared. Biggest mistake is to just put x, right? That would change the equation. Now, what do I always ask myself? Can I continue to factor? So I look at these pieces. Well, what do we think? Can I continue to factor either of these?
You could continue to factor
No. You almost said yes. And a lot of people in this case do say yes, right? All my classes today so far, there were a lot of yeses and a lot of nos, and this class is on it. But you caught yourself. What did you see that made you think, oh, possibly?
I saw the x squared and the 4.
That's a perfect square. That's a perfect square. What's the problem?
It's a plus.
It's a plus. It's the difference of perfect squares. The sum of perfect squares, I can't do anything with. It's fully factored. Okay? If it was subtraction, we could keep going. Okay? So be on the lookout for that in the 2 problems below. I want you to try those now. Okay? Use this method. I'll leave this example up, right? And try to factor those, and then ask yourself the question, can I keep going? And if you can, do it. Okay? Ready to go over the examples? Taking a little stretch break. Okay, so here's our first example. Oops. Did I crash? Okay. So again, we're trying to factor this. We're trying to find smaller pieces that would multiply to give me the bigger piece, right? So I'm looking for what goes in there. So I use magic X. I put the last number with its sign right here. I put the middle number right here, C and B. And then I know it's multiplying to get a negative, so it's got to be a So really, it's going to multiply and then subtract to get me 7. So what 2 numbers multiply to give me 18 and would subtract to give me 7? 9 and 2, right? 9 times 2 is 18. 9 minus 2 is 7. What has to be the bigger number? Negative, right. Because I want a negative down here. So negative 9 and 2. Okay, so then I throw those in. X squared minus 9, x squared plus 2. Okay? So I've gotten the quadratic form part factored. I need to then ask myself, can I keep going?
Yeah.
Yes, why?
X squared minus 9 is
It's a difference of perfect squares.
Yeah.
That's a perfect square, that's a perfect square, that's a difference. When I know that's true, I can keep going. Can I keep going with x squared plus 2? What do I do with something I can't keep going with then? Leave it, bring it down, right? So I would say, okay, this thing is going to become 2 pieces, and then this just stays. Okay? X squared minus 9 becomes? X minus 3, x plus 3. You just take the square root of both, right? Okay? All right, now this is fully factored. I can't go any further. All right, we'll do the other one, and then we'll get to the last piece, and then we will hopefully have some time at the end for you to work. Okay, so for this one, again, I'm just looking for these parentheses that would multiply to give me this, right? That's what factoring is. I magic X. I have 16 on the top and minus 8 on the bottom. Now, how do I multiply to get a positive and add to get a negative? It's got to both be negative, right? It's the only way. And then 2 numbers are multiplied to give me 16, and then add to give me negative 8. Yep, 4 and 4, right? Okay, so this becomes x squared minus 4, and then x squared minus 4 again, right? Just put your puzzle pieces in. Okay, and then I ask myself, can I keep going? Yes, because I have difference of perfect squares. Let me zoom in here, right? That's a perfect square, that's a perfect square, that's a difference. So what does x squared minus 4 become? X minus 2, x plus 2, and then x minus 2, x plus 2. And that is all the way factored, but then what else could you do if you wanted to?
X minus 2 squared plus
Yep.
x plus 2 squared, right?
Yeah, right? So think about if you move this in front, you would have x minus 2, x minus 2. That's x minus 2 squared. Same thing on the back end. So you would say x minus 2 squared, x plus 2 squared. Okay? So that's quadratic form. That's one method that we got to be able to recognize. If you have a 4-2-C situation, try the magic X, try quadratic form. Okay? Ready for the next one? Okay. So the next one is so we talked about difference of perfect squares, right? You got a perfect square, you got a minus, you got a perfect square. Well, what if we have cubes? What if I have a cube and a cube, right? There's something you can do there, okay? So that's what we're going to go with next, the sum and difference of cubes. And because of the way cubes work as compared to squares, actually the sum and the cube work. So this one you don't need a difference. You can be sum or difference. There's two different formulas. Okay, so this is going to look complicated. But it's actually a pretty, if you just learn what to plug in, it becomes actually kind of an easy test question. Because you just need to know what one number is, what another number is, and then you plug them in a few times. Okay, I'll show you what I mean. Okay, so there's a formula for both of these, right? And I'll give you the formula. But first I'll show you some placeholders. Okay, those are our placeholders. A to the third and minus b to the third. This would be the difference of cubes. So one perfect cube minus another perfect cube, right? And before I begin, I will say you don't need to memorize your cubes now. There's a list at the bottom of your notes here, right? Use that list to help you. I'll give you one on a test, right? That's not what I'm assessing yet, okay? Eventually, I would want you to know them, but right now I'm going to give them to you. Okay, so then I have to ask, well, I'll tell you a couple ways that people find are helpful, right? Two things you can do. You could rewrite this as x to the third minus, and instead of 8, what is the perfect cube that's happening there? It's 2 to the third. So you could just write 2 to the third, right? I haven't changed anything, right? 2 to the third is 8, so I just kind of changed the form. I haven't changed any value. Now, why is that helpful? Because we want to know what our a and b is in our situation. These are placeholders, right? What's our a and what's our b? What's the first thing we have being cubed? Not 1, x. What's the other thing we have being cubed?
-2.
2.
Oh, we don't have to.
There's no parenthesis. It's not -2 to the third. It's -2 to the third. The 2 is all that's being cubed. All right? Don't put a sign on your b. Okay? Just take the number. Okay? All right. Now, why was it really helpful to know what our a and our b is? Because the rest of the formula, this is how you factor the difference of cubes. You would say, okay, it's a minus b times a squared plus ab, or a times b, plus b squared, right? Again, it looks crazy, it looks complicated, but if you know your a and b, you just have to plug them into each spot, and then you're done, okay? So let's practice that. So my a is what? X. And then I would say minus, and then my b is 2. Now my b is not -2, my b is 2. Here it says subtract b, so I'm subtracting 2. Okay? And then I would say a squared. Well, what's my a? X, so I would put x squared. And then I would put plus a times b. Well, my a is x, my b is 2. So yeah, I wouldn't put x times 2, right? We always just write 2x. So you just put plus 2x, and then my b squared. What's my b? 2 squared, which is 4. And you factored it. Okay, now, one thing. Remember I said what factoring is? It's taking a bigger thing and breaking it into the multiplication of smaller things. Huh, anybody got a problem with that definition after looking at this? I mean, this looks a lot bigger than that in a way, but what isn't as big? What is bigger there than here? The exponents. That's what you're trying to do. You're trying to break down the exponents, right? The bigger thing into the smaller thing. Okay? Now, what question might you be asking yourself? Can I keep going? I got a trinomial here. Maybe I can magic exit, right? I will tell you, I'm glad you're asking yourself that question. When you do these problems, you won't be able to. The way that this works is that becomes It's not a magic exponential. So you're done. This is it, right? So you can see what I mean. Like, I'm going to give you this formula, and then I'm going to give you a problem like that on a test. All you really need to do is figure out your A and your B, plug them in, and you get the answer right. Okay? Okay? Once you get into the solving part, it'll be a little bit more work, but that's all we got for now. Okay? Now, that's the difference of cubes. But remember I said there's a sum of cubes as well. It's a different formula. So it's very similar, but same process. Okay? All right, so if I have x to the third plus 729, right? Well, now I have a to the third plus b to the third, right? And I want, like I said, a lot of people find it helpful to rewrite the problem as a to the third. So 729, what is that being raised to the third? And again, you don't have to know that. Look at the list, go 729 is what? 9 to the third. Okay, now you asked yourself, what is my A and what is my B? What's being raised to the third? Right there. X. What's being raised to the third there? 9. Right? And now the formula looks like this. A plus B, this will be very similar. A squared minus AB plus B squared. Right? Just flipped a couple signs. Okay? So now you plug in your A and B, and then I'll give you a minute to do that, and we'll see what you get. Okay? The trickiest thing here is, the biggest thing people make for mistakes is they try to assign a sign to their B. Don't do that. Just take the number. And then they use the wrong one. They use the difference one instead of the sum one on the problem just by accident. Right? So just be careful. If you got plus, use the one that says sum of cubes. If you have a minus, use the one that says difference of cubes. Okay? Okay, so if it's A plus B, I found my A, I found my B, what do I write? X plus 9. And then my next thing is A squared. For me, that's X squared. And then minus AB, so that would be minus 9 times X, 9X. And then plus B squared, and my B is 9, so that's 81. And there you go. You just factored it, okay? That's how these things work. Pay attention because you might see problems like this, right? Okay? All right. So, x to the fourth minus 36. So this is actually something that you've seen, even if you don't realize it. Okay? What do we notice? Start with the 36. What kind of number is 36? Hannah? It's a perfect square. What is a minus? What do we call that? A difference. So G is, if only x to the fourth was a perfect square, we would have the difference of perfect squares. Is x to the fourth a perfect square? Well, yes, because a perfect square is when you can multiply anything times itself and you get the thing, right? What times itself is x to the fourth? X squared, right? So this is the difference of perfect squares, right? You take the square root of this one, x squared, the square root of this one, and you minus plus it. Now, I can't keep going because I don't have another difference of perfect squares, right? But maybe you could have. But this is 6, so that's not a perfect square. So that's factored now, okay? And if you fold it, you would find it works. All right, other one. 4x to the third plus 4. Weirder than we've seen. But I know a thing or two about when I see 4 twice. That's a GCF, right? So let's at least see if that clears things up for us. And maybe this is as far as we can go, but it's still factoring, right? I'm still breaking it down a little bit. Okay, so I get x to the third plus 1. Well, it kind of looks like the problems we were doing today. I have a perfect cube, sum, but then I got 1. And I was looking for another perfect cube. It is a perfect cube. Not everybody realizes that, right? Could you think about a number you can break down? And what is the cube root of 1? 1. 1 times 1 times 1 is 1, right? So it's a little confusing, but it's a perfect cube, right? Your A is x, and your B is 1. So you just plug those into the A and B spots, and you do the same thing you did up above. Okay? No? Okay. All right, we're going to get started then. On your homework, you were asked to practice some of those factoring pieces that we talked about. Remember, factoring, all we're doing is taking a bigger thing and finding smaller things that multiply to give us the bigger thing, right? So we're learning different methods for different situations, right? We learned 2 last class, right? And we actually already knew 2. We just might not have realized it, okay? We'll talk about that a little bit. So what were the 2 that we learned last class? We learned 2 methods for factoring polynomials last class. GCF was 1. Grouping. Yep, grouping. Okay? And there's 2 others that you actually already know. Anybody know what they are? So when I say factoring, I mean specifically polynomials. Obviously, with quadratics, we learned magic x, that kind of thing. I'm talking about, like, in this unit, the new stuff that we learned in terms of how to write a factored form of an equation. I'll give you a hint. You did one on your warm-up if you completed your warm-up. Yeah. Well, synthetic division is one. That wasn't what I was referring to. That's one of the 4, though, because synthetic division tells you factors. And there's an example on your homework that we'll probably have to go over, because I have in every other class, that I'll explain how is that factoring. Because it's the same reason that 6 divided by 3 giving you 2 is factoring. It tells you 2 and 3 are factors, right? We'll talk more about that. What's the 4th way? Did anybody finish the warm-up? Feel good about it? Yeah?
Is it the remainder?
How did you get your factored form?
I took the remainder.
Well, not just the remainder. What goes into the factored form? The what? The x-intercepts, the roots. So you can use graphing to write in factored form to get a factor, right? So you factor that equation using a graph. So that's 4 ways: graphing, synthetic division, grouping, GCF that we've learned so far. We're going to learn 2 more today, okay? So different things for different situations. Okay, so we'll start with GCF. I have a feeling I know which one we would want to talk about. What do we want to see? Anybody? 6? Okay. 11. 11 has been popular today. All right, so for 6, okay, when you have a GCF, or when you're looking for a GCF, you're thinking about number, you're thinking about letter, right? So you think about them one at a time. And if it helps you, just write what your GCF is first over to the side, so then you can be like, all right, now I know what I need to pull out, right? So you look at 4 and you look at 100, and you say, what goes into both of those? Like, what can I divide them both by? 4. And then you look at k to the 5th and k to the 3rd. K to the 3rd is the biggest thing that goes into both of those. So 4k to the 3rd is my GCF, right? That's what I'm going to try to pull out of both. So I write that out front, 4k to the 3rd, open up parentheses, and then I divide each of these by that, right? 4k to the 3rd, 4k to the 3rd, okay? And then you do the division. What is 4 over 4? What happens? Cancels. It's 1, so it cancels, right? And then k to the 5th over k to the 3rd. K to the 2nd, because when we have an exponent over an exponent, we subtract. 5 minus 3 is 2, right? So I have just k to the 2nd, okay? Minus, and then 100 divided by 4, 25. And k to the 3rd divided by k to the 3rd, that 1 cancels, so that just is left, so it doesn't, leaves you with just minus 25. Okay, so I've used my GCF, right? I have factored this a little bit, right? Bigger thing, multiplication of smaller things, right? And when we say bigger to smaller, I mean exponent size, right? I had a 5th and a 3rd, now I have a 3rd and a 2, okay? That's what bigger to smaller is referring to. Now, I always ask myself a question. What is that question? Anybody know? Can I keep going, right? Can I continue to factor, right? And then I look at this and I say, oh, k squared 25 minus, what is that? Perfect square, and a difference, right? It's called the difference of perfect squares. And that word difference is huge, because if this was plus, we couldn't do this, right? Difference means subtraction. If you want to remember it as the subtraction of perfect squares, you can. The official name is difference of perfect squares. When you have the difference of perfect squares, you can keep factoring. What you do, 2 parentheses, right? And then you just square root both of the things. They're both for perfect squares. So square root of k squared, meaning what times what is k squared? K. And you put that in both spots. What times itself is 25? 5. So you put that. And then you put minus plus. Okay? Difference of perfect squares. You can do that every time. Okay? You don't need a magic X, or it's just you can just jump right to that. Then you ask yourself, can I keep going? Well, this can't be factored. Any binomial like that can't be factored. So you are done. You have fully factored it, and you know you're done with this problem. Okay? So that's a GCF example. Okay? All right. So somebody asked about 11. I'm going to, in the interest of being more efficient with our homework, I'm going to say you would GCF it, and then you need to use rainbow method. Okay? So if you got stuck, it's because you had a GCF, or sorry, you had a value that was 10, and then you had a rainbow method to finish that. Now, a lot of you avoided rainbow method and just went straight to quadratic formula. That's when we're solving, but if you're just asked to factor, you can't avoid rainbow method. You have to use it. Okay? So if you need to review that or you get extra help with that, let me know. Okay? All right, we're going to move on to our next skill. Okay? So the next one was grouping. Actually, before we do, here's an example of what I was talking about. This is a mistake, right? This person, and this happens a lot, was like, oh, perfect square. I got the difference of perfect squares. What did they miss? Yeah, it's not difference, it's plus, so you can't do this, right? This is actually done, like fully factored at that point. You can't keep going, okay? So that's the difference there. Okay, grouping. Do we have one of these that we would like to see? 23, okay. So with grouping, first step for any of these problems is to recognize the problem for what it is and then decide on your method. So you notice you have 4 terms, and it goes 3, 2, 1, nothing, right? That's an opportunity for grouping. So that's when you would be like, oh, this is 3, 2, 1. Okay, so that might be a grouping problem. So then you look at the groups, right? There are 2 groups. This is a group, and this is a group, right? And you want to GCF each group. So just looking at one group at a time, you ask yourself, what can I divide them by? 1 y to the third and minus 5y squared. What goes into both of those? Y squared goes into both of those. So I would put a y squared out front and divide them both by y squared. Right? That's just backwards distributing. So all factoring is with a GCF is, because remember, when you factor, you should be able to go back to what you got. If I distributed this back through when I'm done, I could get back to this. Okay, y to the third over y squared. We subtract, so it's just y to the 1. And then y squared over y squared cancels, and I get minus 5. First one's done. Now I look at the next one. I have 6y minus 30. So what goes into both 6y and 30? 6, and no y, because this one doesn't have a y, so the y has to stay. We're just pulling out the 6. So I say, okay, plus 6, and then I divide them both by 6. 6y divided by 6, 6's cancel. I get y. Minus 30 divided by 6 is minus 5. Okay, so this next part is where people get a little tripped up. Right, so I'm going to give you the example I gave you yesterday, and I'm going to try to explain it again, right? If I had y squared times b plus 6 times b, and I asked you to GCF that, what would you do? you take out b, and you divide this by b, and you divide this by b, and you'd have what on the inside? Y squared plus 6. Okay, right? Now, just remove b in your head and put y minus 5 in there instead. So y minus 5 is the thing that both of them can be divided by. So that's your GCF that comes out front, and that's why we can do grouping. Okay? So you would say, okay, y minus 5 can go into both, so I'm going to put y minus 5 out front, and I divide them both by y minus 5. And you don't have to show this full step every time, but this is what you're doing, right? And then this cancels, and you get y squared plus 6. And that's why it works, okay? Now, the other thing to check your work or remember is the parentheses that you find go out front, and the other pieces go in the back. Okay, question?
Do we have to do y minus 5 squared? Because like 2 of them, they're...
No. So, did you do b squared over here when you GCF'd b? No. You just pull out the b. You just are dividing by whatever the GCF is, and that goes out front. Think of it this way. Like, this is the GCF. It goes out front. There's no reason to square it. This is what is left over, the y squared and the 6. Okay? So you don't square it. Okay? Make sense? Yeah, question?
So like board A, B, C, how do you know which one's B? Because it has 4 on it.
You talking about this b?
Yeah.
So you can't do this comparison until you're at this step. So y squared times b was y squared times y minus 5. So b equals y minus 5 in my example. Right? This is confusing, so I took out the y minus 5 and I put a b in its place, and then you could see it, right? But now take the b back out and put y minus 5 in, and it's the same concept. It just looks crazier because your GCF is a whole binomial. Okay? All right. Any other questions? All right, there's your grouping example. Okay? Now we'll go to the back.
Can we do 11?
No. Sorry. Okay, so, and maybe we'll have time at the end. Okay, so now this is another way of factoring, but using synthetic division. You're like, how is that factoring, right? Because what is the result of division? Like, I've used this example a bunch of times. If I did 6 divided by 3, what's the answer? 2. And this gives you everything you need to factor 6, right? Now you can say, 6, if I factored it, it's 3 times 2, right? So when you do division, the thing you divide by and your results are factors, right? So now we're going to do division. We're going to get a result. That answer and our divisor are factors, right? You could rewrite 6 as 3 times 2. You could rewrite this big thing as this times our answer if we get a remainder of 0. Okay? And it might make more sense when we finish the problem. Okay, so let's take a look at this problem. So I would do synthetic division, right? I have x minus 4, so what am I going to put on the outside of the synthetic division? Plus 4, right? The potential root. And then on the inside, I put my coefficients. It goes 3, 2, 1, nothing, so no zeros. 1, minus 5, minus 8, plus 48. And then I always like to put a box right away so I don't forget that last piece is my remainder, right? And if it's a 0, that means we have a factor, that means we have a root, that means we can continue, okay? So remember, the first step is you bring down this 1, and then you multiply, add, multiply, add, multiply, add, right? So I multiply by 1 times 4, I get 4. I add, I get negative 1. I multiply, I get negative 4. I add negative 8, negative 4, negative 12. I multiply 4 times negative 12. negative 48, and then positive 48 minus 48, that's 0. So I learned that it is divisible, meaning it is a factor, meaning I can state the following. I can say this divided by this is what? What's the answer to this question? Just the division.
X.
Go ahead, Hannah.
X squared minus x minus 12.
Right. Okay. Now, how is that factoring? Well, we divided and we got an answer, right? So, just like 6 divided by 3 equals 2, meaning 2 times 3 equals 6, factored, well, we can do the same thing. I can say x to the third minus 5x squared minus 8x, plus 48 equals the multiplication of two smaller things, which are what? X minus 4, x squared minus x minus 12. And that's factoring, right? So you might not have realized you were factoring when you did synthetic division, but anytime you divide, you find factors, right? So this is another way of doing factoring, right? Especially if you have no idea where to go, you can just start looking for roots. And if you find them, you've started to break it down. And then you ask yourself, what?
Can I go further?
Can I keep going? And you look at this and you say, well, that's a trinomial. Maybe I can magic exit, right? So you focus in on this one and you try to magic exit. And you go, okay, minus 12, minus 1. Two numbers that multiply to give me negative 12, add to give me negative 1. Negative 4 and 3. Right? That multiplies to give me negative 12. It adds to give me negative 1. Right? So this part now breaks into two pieces. This just comes down, and I get x minus 4, x minus 4, and x plus 3. And look at that. Looks factor to me, right? And I use synthetic division to get there. What do you think?
You can take out one of the x minus 4s and just square it with the other.
You could also write it this way. And actually, this, where we're going, has benefits. If you see a factor squared, it tells you something, and we'll get there. So, there you go. That's synthetic division to factor. Okay? Does that make sense?
Yeah.
Okay. All right. So, we hit on all the skills in the homework. We're going to move on.